Hi guys, in this video I will tell you about the uh, string theory. What is string theory in mathematics basically? String theory in mathematics has had a profound impact in the development of mathematics. I indicate how string theory can be considered as a two-parameter deformation of classical geometry, where one parameter controls the generalization from points to loops, and the other parameter controls the quantization in terms of the sum over topologies of Riemann surfaces. The final mathematical formulation of non-perturbative string theory, which is not yet there, will have to bring together geometry, non-commutative algebra, and loop surfaces. Over the years, string theory has been able to enrich various fields of mathematics. Subjects like algebraic and differential geometry, topology representation theory, infinite dimensional analysis, and many others have been stimulated by new concepts such as mirror symmetry, quantum cohomology, and conformal field theory. In fact, one can argue that these stimulating influences in mathematics will be a lasting and rewarding impact of string theory in science. Whatever its final role in fundamental physics, string theory seemed to be most complex and richest mathematical object that has so far appeared in physics, and in inspiring dialogue between mathematics and physics that it has treasured in blooming and spreading in wider and wider circles of mathematics. Physics and mathematics. This synergy between physics and mathematics is definitely not a new phenomenon. Mathematics has a long history of drawing inspiration from the physical science, going back to astrology, architecture, and land measurements in Babylonia and Egyptian times. Certainly, this reached a high point in the 16th and 17th centuries with the development of what we now call the classical mathematics and mechanics. One of its leading architects, Galileo, been us has been given us the famous image of the book of nature waiting to decoded by scientists. Philosophy is written in this grand book, the universe which stands continually open to our gaze. But the book cannot be understood unless one first learns to comprehend the language and read the characters in which it is written. It is written in the language of mathematics, and its characters are triangles, circles, and other geometric figures, without which it is humanly impossible to understand a single word of it. Without these, one is wandering in the dark labyrinth. This deep respect of mathematics didn't appear after the 17th century. Again, in the beginning of the last century, we saw again a wonderful intellectual union of physics and mathematics when the great theories of general relativity and quantum mechanics were developed. In all the centuries of the mathematical world, this was closely watched, and mathematicians actively participate. If anywhere this was so, Göttingen, where Hilbert, Michigan-Whaley, and Newman and many other mathematicians made important contributions to physics. Theoretical physics have always been fascinated by the beauty of their equations. Here we can even quote Fermat, who was certainly not known as a fine connoisseur of higher abstract in mathematics. So thank you so much.